Good evening, everyone, and welcome back to the Architecture Education Online Lecture Series, proudly presented by MASA. This is our 12th lecture entitled, Even Architects Should Learn to Program by Dr. Taki, Eddine, Seghier. Thank you for joining us tonight. For those who are new, MASA stands for Malaysia Architecture Students Alliance. It is a non-profit student committee acting directly under PAM, also known as Pertubuhan Arkitek Malaysia, and it consists of student representatives from all architecture institutions in Malaysia. During this time of RMCO, MASA and PAM have decided to launch this online lecture series for students to be more productive and gain more insights. Architect Adrianta is the head of PAM Education, and Dr. 𝐂𝐲 is the convener. There will be more series coming up after this one, so do keep in touch with MASA's Instagram and Facebook page. My name is Janelle Lansing, a MASA representative from UPM, and I will be your MC for tonight. Now, I would like to introduce our guest speaker for today, Dr. Taki. Dr. Taki Eddine Seghier has obtained his PhD in architecture from University Technology Malaysia, UTM, in 2019. Currently, he works as a lecturer at UCSI University, Kuala Lumpur. His area of interest is BIM, which stands for Building Information Modeling, and Sustainable Architecture. He is passionate for teaching others on how to utilize technology in the architecture, engineering, and construction AEC industries to improve design efficiency and apply sustainable building design principles. Now, I'm sure everyone is looking forward to the lecture. And remember, we will have a Q&A session at the end of the talk. If you have any questions, feel free to type them down in the chat box so we can attend to them at the end of the sharing. That is all from me. Dr. Taki, the floor is yours.
All right, thanks, Mr. Jaman. It's a pleasure for me actually to participate in this event, and thanks again to MASA for giving me such an honor to do this presentation. And thanks for the attendance. And hopefully in the end, you will find you have learned many new things actually. So as you can see, the title of this presentation is Even Architects Should Learn to Program. The content of the presentation is as follows. So in the beginning, we will try to answer this question, why programming is important. And after that, we will talk about programming fundamentals. And then we will focus on something called visual programming application in architecture. And in the end, there will be programming in architectural research. So the last one, maybe it would be a little bit complicated because it's basically for master students or PhD students or those who are doing research, but I think it can give you good ideas how to apply programming in research in architectural field. All right, so let's start. Why programming is important? So this is the big question of this talk. So we have to know actually this thing is that the world's most valuable resource is no longer oil, but it's data actually. And this has been issued by The Economist 2017. And of course, it's still applicable until today. As you can see in the image, these companies, these big companies in the world, actually their business is based on data, actually, how to manage data, how to extract data, how to organize data, etc. So big ideas actually now that are based on data and not oil as before. Now, it's important to know there is what we call it industrial revolutions. So we have the first one until today we are working on this fourth revolution. And basically, these revolutions that are evolving. So from water power in the beginning, and nowadays we are thinking about how to manage data, big data, things related to artificial intelligence, things related, for example, machine learning. So all these buzzwords are now actually in nowadays live actually. And actually there is even sometimes people, they think that architecture, as we know, is likely to disappear, and in the future, the role of architect may be very different to how we recognize it today. So, which means we really need to find or to update our toolkits in order to be to date with current technologies. If we see, for example, car industry, look before how it was and look now how it is. So basically, robots have invaded the factories of, and as you can see, almost we cannot see any person here in this, in the current situation in car industry. Same thing now, if we see what is happening in architecture. So for example, we started by hand drawings. So this is how things look like, and then AutoCAD, 2D and 3D. And today everybody is talking about BIM, building information modeling. And the big difference between, for example, BIM environment and CAD is information. So this means if you have the weapon or the tool to manage this information, you will survive. Of course, all the surrounding actually, either robot, video games, or even your air conditioner at your current room, actually there is always programming. There is a place for everything actually in nowadays life. Even for architecture, these buildings actually without programming, they will never be standing like this, like in these pictures. So programming, there is always a space where you can apply programming, even in the design process. And this is what we will focus on after that. So I believe if I ask you, for example, maybe if you would like, what architect you would like to be in the future, or many, I think maybe they will say this guy, Le Corbusier, because he's very known that he's a very good architect. This is, I can't tell you this is maybe before, but nowadays you have to be like this. You know, the second half is Bill Gates. So basically you need to think like Bill Gates also. So you need these two persons. So the Corbusier mind in order to think in like how to design or and everything related to architecture, but in order to embrace the current technologies, you have to think also in like this guy, Bill Gates. So now if we take a look to the brain of our brain, so basically, you know, we have two parts, and the right part, everybody knows that it focuses on things related to creativity, things related to drawings, and things related to colors, aesthetic, which are generally very subjective actually. And when we are practicing architecture or when we are designing, our right brain will be very active. But I believe nowadays we need to make this left brain also active. So, and actually programming, things which are related to logic, they are all here. Strategic thinking, decision making, they're all here. So this means it's like there is a gap between these two fields, and we have to find a way how to like combine them together in order to survive as a good architect. And you have to know that like Steve Jobs is saying here, I think everybody in this country should learn how to program a computer because it teaches you how to think. It's not because it will bring too much money to your pocket, but it's because it will teach you how to think. So, and of course, everybody wants to learn new skills to improve his way of thinking and to improve his decision making. Which means actually it's not only for architects, even that's why in some schools you can see this kind of people, what they are doing here, these kids, they are learning programming actually. Just for your information, there is already a software called Scratch, and it has been developed by MIT, and actually it's oriented for children to learn programming. So for example, this is a small program developed by a kid. So as you can see, it's like the mission is to move this small cat from this green apple to this red apple. So they should develop like an algorithm to make this happen, to reach the objective. Another thing you have to know. Now I'm trying to to give you good arguments why programming is important. Remember, so another good argument is that there is a survey that was done by this Stack Overflow survey. They are a very known company, and what they did actually they did a survey for 26,000 persons, which they are developers actually in computer science. And these persons, they come from 157 countries. And one of the findings they found actually is this: 48% of them, they are self-taught and they are without computer science degree. So this is very important. This means if you are an architect, if I ask you to learn programming, I'm not asking you to go and take a degree in the University of Computer Science. No, programming, it's like English. So if you can learn English, you can select a language of programming and you learn it. Of course, there is too many documentation in the internet nowadays. So basically, we need just this motivation, and that's why I brought this talk for you. We still, of course, I still didn't give you arguments why it's important in architecture. We will see. We have case studies after that, and all these things. It's good to know that these are the benefits. If you learn programming or coding, it will help you to master your tools. For example, now you think you do well using Revit, but if you learn programming inside Revit, if you know how to do programming, like develop macros or maybe use Dynamo, if you know Dynamo, it will help you to learn Revit more and more. And second thing, it will help you to solve problems, because this programming is always based on how to develop in logics and make conditions. If this, give me this, so you are giving instruction to the computer. So it means it will help you to solve problems. And of course, it will help you to think algorithmically. If you wonder what is algorithm, we will explain what is algorithm. And programming, actually, it's fun. So if you learn how to do it, you will be addicted, actually. You will always like to do programming if you really like it. And somehow it helps you to work lazy. What do we mean by lazy? It's not the negative meaning, but I mean smarter, not harder. So as this guy said, Walter, so whenever there is a hard job to be done, I assign it to a lazy man. He is sure to find an easy way of doing it. So here, lazy doesn't mean lazy in the negative sense. It means those who always try to think smarter, not harder. All right, so now I gave you some arguments why generally programming is important. We didn't talk about architecture. So before I talk the application of programming architecture, I want you to know some basics or fundamentals regarding programming. So the first thing, you know, Revit, for example, is a software, and basically it was developed by Autodesk, and basically it's a program, a program. And you have to know that all these tools, if you are familiar with Revit, all these tools, behind them there is a small script, and this script is kind of a program. It's like sub-program in Revit. So when you click here, for example, small program will be executed. So what they do, these companies, they develop many tools, small programs like this, and then they combine them in the toolkit like this, and they sell it as a software like SketchUp or any other software, or Revit or AutoCAD. It's important also to know what is the difference between information and data, because it's confusing a little bit. We cannot use them interchangeably. And actually the main difference is that data, we have data. In order to get information, you have to process the data. Now, how to process the data? I have examples what we mean by processing the data. So basically, for example, here from A in order to go to B, so we have data, which is the paddy rice, and we want to get information. So basically, we need to go through a process. So in the beginning, we have paddy rice, we process it, we dehusking, and there is parboiling. And this brown rice, from the husking we go to brown, we get brown rice, and then milling, and then white rice. And actually you have to know that all this process, since there is a process, we call it, what we call it in computer science, we call it algorithm. So now you know what does it mean, algorithm. So basically it's a series of instructions that we give it to a computer. So we have data, and we have objectives in order to get the useful data, which is information. So this is what is an algorithm. And now you know what is the difference between data and information. In other words, let's say we got that information, which is rice here. We can go through another process. We can apply another algorithm. So we take this input, we add like carrot and these other vegetables. We slice them like we are doing, we filter things which we don't need. And we put them here in this cooking recipient, and we add variables. As you can see, we can add like any kind of even salt, and then in the end we will get the output which we can eat, of course. So now we applied kind of an algorithm. So this is an algorithm, because I know sometimes students are scared when you say algorithm. You think you are talking about rocket science, but algorithm is a very simple thing. Is series of instructions that we give to the computer. Okay. Now you may wonder, you know, in programming we have too many languages that we can select to do programming, and these are text-based computer languages. There is too many, actually. There is thousands, but there is few of them that are very known, like this Java. Maybe you heard about Java, Python, this C++. But these text-based computer languages are a little bit hard to learn, or they may take time to learn. And of course, computer scientists, they have to learn these kind of things. We have another thing called visual programming. I will talk about it in a moment, but let me give you an example. For example, to develop a software which when you execute it, it will write this thing, hello world. So here we have two languages, C#, we call this one. And as you can see, there is few lines we have to write them in order to make the software say hello world. And regarding Python, the language, it's very simple. So it's like there is a syntax, there is a specific rules how to write the language. So in order to write a software which gives you hello world when you execute it through Python, it's very simple, as you can see. Another thing I want you to understand, actually, when you are using Revit, for example, or any other software, you as the user, you are here. And Revit is here. And between you, there is something called API, which is Application Programming Interface. So basically, when you are interacting with the API, anywhere you click on Revit, you are giving instruction to this API, Application Programming Interface. And this Application Programming Interface will talk with the operating system, which is Windows, for example. And of course, Windows will talk with the hardware, which is your computer, processor, and all these things. These are very basic things, just to prepare you, to give you an overview about the basic or the fundamentals of programming, because things, they go this way. Now let's talk, for example, about Revit. I mentioned you are the user, you have the user interface, and you are using Revit. You can imagine it like this. It's like Revit is the kitchen. It's like it's a restaurant, and Revit is the kitchen, and this API is the waiter. So when you are clicking on the interface, you are asking the waiter to bring specific food, like 𝐾𝐫𝐜𝐿, for example. You click on wall in Revit. Of course, you will not click on 𝐾𝐫𝐿, but it works like this. So when the API will go to the kitchen and bring what you are looking for. So this is very known, actually, in computer science, so application program interface. which means in this case, if you want to go behind the scene of this kitchen, which is Revit, you have to work, you have to try to make some programs which can talk with this API, application programming interface. In order to talk with the application programming interface, as I mentioned, there is text-based languages which are a little bit hard compared to visual programming. And the second way is to use visual programming languages like Dynamo or Grasshopper. I think some of you, they know these softwares, at least the name. So this part, I will now focus on visual programming application in architecture. I will show you many case studies now. So now it's really related to architecture now. So the priority one is architecture and then programming. Before that, I just want to explain what is visual programming. So actually there is, as you can see, several softwares. These are visual programming tools, including Dynamo. Dynamo, for example, is connected with Autodesk Revit. Marionette is connected with Vectorworks. Grasshopper is connected with Rhinoceros. And recently it has become connected with ArchiCAD also. And there is generative component which is connected with this Bentley micro station. So remember, again, these tools, I will focus now on Dynamo basically. So these tools are visual programming tools. So instead of writing text, we use components. I will explain to you how these components work. So in order, like something to remember, so Dynamo, when we talk about Dynamo, for example, and Revit, you can imagine this thing. So Dynamo, it will be like a marionette for Revit. So if you want to move Revit in any way, you can use Dynamo, because Dynamo can talk with the API of the software Revit. Now, this is the difference between text-based programming and visual programming languages. So this one is text-based programming. As you can see, it's writing, and it really needs time to learn this kind of things. So it's not, but this one, visual programming code. As you can see, we are connecting, it's the same code, but we are connecting here just boxes. And these boxes, behind them, there is small scripts. So the idea of this visual programming is to make things simple. Instead, you as an architect or an engineer, instead of focusing or start learning this complicated text-based programming, they give you nodes like this, which you can connect together using these, we call them wires, and you will develop a program which will be able to do something. Now, this is like the anatomy of we call it node in Dynamo. As you can see, the most important thing, it has input and it has output. So for example, here, for the sake for explanation, so for example, in Dynamo, if you want to draw a point, for example, which is the very simple thing. So basically you bring this node, and the point, you need coordinates, basically X, Y, and Z. So there is number here, you put 2 or 3 or any number, and there is this kind of thing, they call it slider, and you will be able to change the amount of Z, and you will see it in Dynamo, it's going up. Remember, actually this Dynamo is connected with Revit. So this means anything you do in Dynamo, it will happen in Revit also. So this is another example, just a Dynamo script, which will create a line for you. These are very basic things, of course. So of course, line, what we need minimum 2 points. So basically we call line by start point, end point. We have start point here and end point here. We call point here, and coordinates here and here. And as you can see now, these points have been created. If I change the Z, for example, you will see this point, it will go up. Basically, this is how programming works. Even in Grasshopper, it's the same concept, actually. Now, before I start showing you the examples or the case studies, how to apply this in architecture in your projects, I will make sure that you know the advantages. So by using programming, either actually visual programming or text-based programming, what we can do, we can automate repetitive tasks. For example, if you go to the industry and you start using Revit, you will see many tasks are very boring. Actually, you spend too much time in order to do them, and it's like you are repeating it. So you start thinking, oh my God, maybe why we cannot like develop something so I can click once and everything will be done. Why I should keep renaming, for example, all these kind of issues. And it helps you actually programming in to create design options, many design options. Because you now in design studio, usually you just create one design and you take it to your lecturer and you tell him this is what I did. But and of course, possibly it's not the best design option. There is a high chance it's not the best design option that you have selected, because there is thousands or unlimited options of material, unlimited option of shades, maybe orientation also, many options. So it's really hard, like a human being, just to select options like this. It's really hard. We need this kind of programming. And it helps you in what we call it in data mining and visualization. Like in BIM, because we have a BIM model which is full of information, so we can extract information and we use it in any beneficial way. And when we develop a script in Dynamo or Grasshopper, we can use it anytime actually. There is something we call it parametric design. So we can build parametric volumes or shapes, and we'll have the parameters, and we can change. So it's very helpful. I have basically examples for all of these. There is something called standard compliance, for example, for fire protection, for fire at buildings. We need to make compliance. We can develop scripts that will detect if you are respecting the regulation related to fire or not. Things related to sustainability analysis, we can do lighting simulation using programming like Dynamo or Grasshopper especially. It is also the fabrication of complex forms and geometries. And the good thing, these softwares like Dynamo or Grasshopper, actually they can communicate between different softwares. So you can connect it between Rhinoceros and Revit and AutoCAD and SketchUp. So there's many workflows. And of course, is expand your design software capability. As I mentioned before, if you are using Revit, if you start using Dynamo with Revit, you will find that you can do many new things actually, which you cannot do only with Revit. And of course, it teaches you the design software. So if it is Revit, you are using Revit and Dynamo, you will learn Revit more when you are using Revit, because it's like when you are doing programming, you will go behind the scenes of the software. And the last thing, it will like make you a prosumer instead of consumer. So instead of buying or using Revit as a consumer, you are consuming the product. When you start using programming, you will be able to develop your softwares, and instead you will not only consume, you will be producer also. Okay, so now let's talk about the examples, especially like the Hadid project. Most of the cases they use actually Grasshopper in their design studio. Grasshopper and Rhinoceros actually. You see these complicated buildings, maybe you can do it even using SketchUp, but when it comes to fabrication, when it comes to real life, because we need to build this kind of complicated forms, you may find it very difficult actually. And sometimes it's even impossible to build it. We need to know the coordination of each panel. As you can see here, they are very like curvilinear geometry. So if you come to build it, and as you can see the structure, how it looks, if you come to build this kind of things, you will find it very challenging. So without this programming tools, you will not be able to make it. Another application of programming, for example, usually we need to, for example, this what we call it kinetic facade or dynamic facade. Usually we have to simulate the movement of this facade, how it will adapt. I think you know this project, so it's Al Bahar Tower in Dubai, and you know this facade will be opened and closed depending on the sun position. and the thermal comfort inside the building. So it's like there is sensors, and these sensors, they are connected with the this pattern in the facade, so which will open and close depending on these variables: thermal temperature inside and solar radiation. So if the sun is behind, so it's okay, we can open it. The sensor can detect there is no sun, it will be open. These kind of things, we need to model them. If we are in design stage, we have to model them using computer software, and we have to simulate this movement. And actually, sorry, we can do it actually, for example, using Revit and Dynamo, we can do it. There is a whole workflow, and there is actually videos in YouTube how to model these adaptive facades. And you can connect after that the position of the sun with the movement, or the, if it will open or it will close, as you can see here. So it's like we do simulation. So if you bring this to your lecturer and you show him, look, when the sun is here, it will close, it will be very good argument in your design studio. So it's not just, look, the sun is here, and I designed my pattern to be closed and open, but you didn't bring enough proofs. But if you simulate it, it's really strong arguments for your design. Another important thing we can do using these tools, you can generate what we call it random patterns. You know, nowadays we have many projects which they have randomized patterns in the facade, like this one, or this tall building with this panels, white panels. So they are random. There is good workflows in programming to make this randomized patterns. So it's like you can test many patterns. And of course, it's very good to use these tools to make, like here in Grasshopper, we can do parametric modeling. For example, this is for the furniture, but we can apply it also for a building. As you can see here, we created parameter, for example, this pose, weight, and height. And since things are parametric, we can see, or we can experience the different options that we can do of this design. This is another example. So as you can see, it's room. If things are parametric, and of course they should be objective. It's like maybe here we don't have big space, so we're trying to select the optimum size of the furniture. Of course, for structural design, also, as you can see, this one is Revit, and here this structure has been designed or modeled using Dynamo. So it helps a lot. Same thing here, we are instructor also. Same thing here, we can, it's parametric structure, so which means we can experience many shapes. We can test many kind of shapes depending on the parameters that we have selected, where the structure will be able to move. So as you can see, same structure, but this, for example, here there's a variable which we can move and see if it is interesting or not, depending on our objectives. Of course, if you cannot do in SketchUp this kind of things, you cannot do parametric design in SketchUp freely as Dynamo or Grasshopper. Here is another, for example, Dynamo for design option. So which means we can create too many options, and after that we can select the best one. As you can see, we created different patterns, and it doesn't really take time to create this kind of pattern. So you create many patterns, and then you select the best one based on your objective. So this one, it was done by Dynamo. Same story. So this one is related to the structural designs, and we're trying to create different options. So these softwares, visual programming, of course, we can do this using text-based programming, but architects usually are encouraged to use visual programming, especially in the beginning, because the other ones, they are a little bit complicated, but these ones, visual programming, are more friendly for user. Another thing, for example, it helps actually for fabrication. For example, as you can see, this kind of ceiling, which is kind of sculpture connected to the ceiling. and it's real here. And actually, they made it using rhinoceros, but they used, as you can see, this one is grasshopper, and this is the script which has modeled this one. So actually, the advantage when we model it using grasshopper, we will be able to get, as you can see, it's not simple. As you can see, there is kind of it's curvilinear, as you can see. Almost, I think there is no element is similar to the other one. They are very different. Which means when we come to produce this one, if you do it in SketchUp, we'll find difficulties in order to cut them, to slice them, and manufacture them. But when we use programming, like visual programming of Grasshopper, we will be able to get exact measurement, and we'll get ID for each element, and it will be ready to be printed or cutted. After that, we will just need to install them very precisely, and we'll get the good result as we were hoping to see. This is another example. This was done by a student called 𝐿𝐿𝐴𝐻. This student is in USA anyway. It's not here in Malaysia. But this student, in his master final project, he used visual programming a lot. He used Grasshopper. Let me show you how did he use Grasshopper or visual programming. For example, his project, he has a big project, and for example, as you can see here, it's an arena. And actually, he has auditoriums. So his idea, actually, these seating should rotate. So we should not make two seatings like this, one for the arena and one for the auditorium. Since, for example, they play basketball in weekend, so the seating will be this way. If other days they need auditorium, so they can rotate. Now, if you don't know programming, you will stop here. You will not go deeper in your idea. But when you know programming, you will be able to simulate the mechanism of your seating if you propose something like this. This is his proposition. As you can see, he's explaining here the structure. So different components. So how the mechanism will rotate in order to make it possible. As you can see, it has been rotated this way. And of course, there is a script. He's showing things are precise. They are not just artistic. Things are precise. And you can, of course, if you zoom here, you will see kind of rotation because it's a variable. It's parametric. So it's like you start moving the the slider here, and you will see that the seating, they are moving, they are rotating. This is the same thing, the same student work. So for example, here he has louver, as you can see, louver system in the facade, and as you can see here, it's going in a very long facade. Actually, it's covering a very long facade. But the issue is that this louver is covering sometimes, like here, there's a corridor. Sometimes here, like there's a cafeteria. Sometimes auditorium, another cafeteria. And his idea, he wanted to make to protect the spaces, or to design his louver depending on the solar radiation and the function of the space, because we don't need solar radiation, for example, in the auditorium here. We need it for here, maybe it's okay since it's a corridor, but here no. So this means we need an idea to make a complete louver, and where we can make it parametrically, and where we can experience how to change the openings of this louver system. As you can see, he has created many patterns of this louver system. And after that, so he used Grasshopper, which is a visual programming tool. And well, the process here, they use what they call it attractor point, but no need to go to the details for now. And since Grasshopper can be connected in 𝐾𝐞𝐬, which is a simulation software for things related to environmental design, so he was able to to perform simulation for the radiation for each elevation and see if like the radiation is too high or too low in some areas. So he has kind of rational thinking how to argue about his design using this kind of technology, as you can see. By the way, he got the best project in his among his student semester or year. Uh, so this is continued. So he did, as I mentioned, ecotech analysis for summer and for winter, as you can see here, regarding the radiation for each pattern. And well, this is the end of his rendering. So of course, after that, he selected the best one, which is normally this one, this kind of pattern. And he has strong arguments why this is the best one. Not just he select and draw. He has argument even about the selection of the louver. And of course, thanks to programming. Otherwise, he will not be able to get this kind of results and workflow. This is another script developed by another student. So that basically this script is it's like to optimize thermal and dilating of the interior space. As you can see, there is many kind of many, we call them nodes, these ones. So the objective is to optimize, as I mentioned, the complex thermal and dilating. Okay, this is another example also. It has been done using Grasshopper, this one. So it's the optimization of EUI, which is energy usage intensity and thermal autonomy. So they use this visual programming to optimize these. And as you can see, you can get results, and after that you can draw a diagram of the performance of the building. And all these results are actually coming from this visual programming tools. This is another example where we can, this one is using Revit and Dynamo. So we have developed, as you can see here, a kind of a pattern for the facade, and we repeated the pattern. And this pattern, the same thing, since there is the sun, so this pattern should be open and closed depending on the position of the sun. As you can see here, it's open a little bit, and here it's, sorry, here it's more open, as you can see. Maybe the sun is in the other side, that's why. So it's important, it's like to do simulation. When you have an idea, especially when it is related to dynamic facades, you need to approve it. Maybe you will not need to develop like a model, a physical one, but digitally you can approve it. You can do simulation for the mechanism. Actually, nowadays, you know, there's what you call it optimization. And in optimization, we use algorithms, and there's many sophisticated algorithms until actually we can just give some data to the software, to the algorithm, and the software and the algorithm will give you the best design in terms, for example, of daylighting, or in terms of cost, or in terms of both cost and daylighting, and even energy maybe. And you will see something like this. So because your initial model is parametric, so when you run the software, you will see the software is testing each possibility or its option. And in the end of the day, it will show you, look, this is the best option. Why? Because look, it doesn't cost too much. It doesn't cost too much, for example, this one. And regarding daylighting, it will be perfect. And maybe even, for example, the energy consumption, it will be very less. So you have to select this option. So as you can see, digital development are really, sometimes they are even scary, because it's like sometimes you may think maybe we will not even need architects to do this, because softwares, they can take decision better than us. They can test many options, they give you the best one. But anyway, this is another discussion. And one of the very advanced, maybe kind of exercise that we can use through visual programming. Nowadays we can integrate hardware with visual programming. For example, this is Dynamo. Let's say we have a window and we have shading device. And let's say this shading device can move, or maybe this opening, for example, as you can see here, they are closed and here they are open. Same thing for this louver. So there will be a sensor, as you can see here, there is a sensor. And this, so this, we call this Arduino, and this Arduino is connected to Dynamo script that you have developed. And for example, when you put your hand on this sensor, which is for lighting, for example, when you put your hand, you will see in your computer that they have been opened, because they know, because they are all connected. So even though the hardware is realistic, so it's under your hand, so you will see that when you cover the sensor, these louvers will open. It's like you are giving instruction to the computer from the hardware. So it's very important to know that we can do this even nowadays. Now I will try to go quickly about some other case studies. Now I will talk about the benefit of Dynamo for data management and automation. Maybe this part, you will not feel the importance of this part only when you go to the industry and you will face too many issues when you are using Revit. You will face that, you will see many things that are repetitive, and you will see that you are wasting your time. So perhaps you will need to use Dynamo that time. For example, let's say you have this issue. For example, I ask you the number of the room by floor level, and I ask you, can you make the numbering of the room by floor level and room name? Because now if I see the numbering of this floor, of this 2D floor, it's saying 28A, 08, and 07. If I give you a table like this, I ask you, I want each room, let's say room in level 1, it has to contain the room number should be like this, so 101, which means it's like level 1 and room 01, level 1 and room 02. And I give you this, this is the level 1, the current naming. As you can see, if you don't use Dynamo, actually what you will do, you will go through this naming one by one. So for example, where is room 1? You will make it room 101. 102, you will make it this one, and so on. But actually, if you have Dynamo, you can develop a very simple script which will do this in a blink of an eye. You just click and all the naming will be changed automatically. This thing maybe you will not need it currently when you are studying, or when you are studying, but when you go to the industry, you will face this kind of issues, especially when there is too many rooms. So this is what we call it script logic flow. We can apply this actually in order to get in order to solve that problem. So basically it works like this. We have to ask Dynamo to gather all room elements. We can do it, and then read each room's level name and read each room's number, and also gather the last character of the room of level name, and then join these number and room level number and room number, and then write this information to the room here. So this script, or this is an algorithm, as I mentioned. So there is like an instruction that we are given to Revit through Dynamo. So sometimes, for example, if I give you this project and I ask you to use Revit, and I ask you to rotate these settings 90 degrees, what you will do? I ask you to rotate all of them, what you will do? Basically, if you select all of them and you click rotate, if those who knows how to use Revit, and you click rotate, actually all the settings, they will rotate not on their axis, they will rotate on a specific point. For example, if I click here as the axis where they will rotate, maybe they will be even outside of the room.
So in order to make this happen, actually we need to develop scripts using Dynamo. And in a blink of an eye, we can execute it, and you will see all the settings they have turned 90 degree in a few seconds. Same thing, for example, as you can see these columns, if I ask you to rotate them using Revit only, you have maybe to start rotating one by one, which is time consuming. Imagine you have thousands or I don't know, hundreds of these columns. So it's really time wasting, but if you know how to do programming, you develop small script, you click, you will see them, they have been rotated automatically actually. For example, this is another kind of an issue that you may face. For example, there's this international building code. So it defines the occupant load as the total number of persons that might occupy a building or option, therefore, of one time. So the equation is occupant load. It's equal to room area divided by occupant load factor. These informations that are inside the rooms already in Revit. If you select a room, you will find this information. So what you can do, since in this code they ask you to calculate it, you can develop a small script like this one in order to calculate it. And when you execute it, of course using Dynamo, automatically you will get the results. And you will not waste your time each time you have a new project. You can always use the same script. Of course, as I mentioned, you will not face this kind of issues in when you are studying. These issues will happen when you go to the practice. You will see them, especially when you are using Revit. Let's say, for example, if I give you this kind of floor plan and I ask you, it's like a small auditorium or class, and according to the standards, each seat should be within 2.5 meters from at least one outlet. How can you prove or how can you make sure that this rule is applied? It's very hard to do it manually. Maybe you will just start like assuming. And sometimes when it comes to regulation, there should be no assumption actually. So using Dynamo, there is a very good workflow how to do this. If you know Dynamo, you will basically, this kind of workflow we can apply, and we will be able to check and make the seating which doesn't respect that rule, we make the color red, for example, we'll see it. So it's like you can develop your software actually to help you. Another thing, we can use Dynamo for what we call it that data mining and extraction. Because, you know, I told you when we have a BIM model, there is too much information. Sometimes we need specific information, so we need to extract these informations. Basically, we can extract them using Dynamo if we wish. And of course, we can send it to Excel and all these things. This is another example. Okay, so this is the last part actually. So programming architectural research. As I mentioned, this part is more for those who want maybe in the future to pursue master by research or PhD by research. Because actually the next slides are from my PhD thesis. And because I use Dynamo actually, I will try just to explain roughly. So if you understand the big idea, it's already good enough. So what we did in my PhD, one part of my PhD, actually we developed a kind of a tool with using Dynamo, of course, Dynamo scripting. And I was in architecture, by the way, so I'm not a computer scientist. No, I'm just like you. So we developed a tool which is able to automate the assessment or the calculation of something called OTTV, which is overall thermal transfer value. Just briefly, overall thermal transfer value is like a metric that we use in order to understand how much heat gain will enter to the building through the whole building envelope. That's it. And usually, currently, actually, they are not using Dynamo. Of course, they do calculation manually, and there is too much paperwork. Sometimes it's complex. Sometimes mistakes can happen. Sometimes, not sometimes, every time actually it's time consuming. It can take weeks. So our idea was to develop a script to extract the information from a BIM model and send it to Excel and give you the calculation automatically. And this is the two scripts that we developed actually using Dynamo. So this is the overall workflow of the script. And we applied our script because in research you have actually to test what you developed. You test it on the case study and you prove that it works. And this is a little video about the case study. So basically this is the case study in Revit. And it's office building. And this is the Excel sheet that we developed or we created. And as you can see, this Excel sheet is ready to host some data that we will extract from this BIM model. So now I will execute Dynamo scripts. This thing we call it Dynamo player. So it's within it's the same as Dynamo. So this is the first script. As I mentioned, there's two scripts. This is the first script. So all this script is just to extract very important information that we can use to calculate this OTTV, overall thermal transfer value. This script is for walls. Me also, I don't really know too much about programming, text-based programming, but this one I learned Dynamo and I know Python regarding regarding text-based programming. So now, as you can see, I'm counting how many seconds it will take to extract the information. Remember, before I mentioned that these kind of things, they can take weeks actually to do them. But now, since I developed this script, basically it will do things automatically. So I think it's about 33 seconds. It will stop. It will finish the process. Okay, 27. So already, as you can see, I got the information here. These informations are automatically coming from Revit through Dynamo script, because Dynamo is connected to Revit, if you remember. Now I still need to execute the second script, which is for Windows. I need to get the information of Windows. Of course, all this script has been developed, okay, as you can see, very quickly. We got the informations automatically without manual calculations on. So basically, this is the OTTV value of this building. As you can see, we did this in a few seconds. And usually it takes weeks actually to get it. And after that, these things are related to research, so we compare to manual calculations, etc. And in another project, actually, this one is a research project. It's like we tried to integrate what we call it optimization algorithms in the same workflow. So instead of calculating this OTTV, we tried to optimize, and we wanted the algorithm to give us the best option automatically, not us to select this is the best wall to use here or this is the best window. We wanted to use an algorithm in order to give us the best option. Of course, when we use algorithm, we'll get the best option in very in short time. So there is no headache, there is no too much paperwork. So everything is automated. And actually, the industry is going to this kind of technologies. That's why the title, even architects should learn to program or how to program. Yeah, well, this is the workflow of the script, how it will work, how it will extract the data. Yeah, this is the workflow, how to push back the data to the model in order to update the optimized result. And after that, these are the kind of results that we got. So basically, we were able to reduce the value of this OTTV from 50, which is too high actually, to 25.96. And of course, there will be like a benefit in terms of cost also. We can calculate even the benefit or how much cost we need to invest to get these results. These kind of things are very important in research. And this is the overall like things related to the speed. As you can see, basically the whole workflow took only 9 minutes. Now, I know some maybe they are wondering from where to start. So as I mentioned, I think actually as architect we really need to start using Dynamo and Grasshopper. We need to learn them. So if you ask me what is the difference between Dynamo and Grasshopper, you know they are from different companies, but Dynamo is in my opinion, is better for data management, like because it's connected to Revit, and Revit is a BIM software. So it's very flexible in terms of data management, how to extract data, how to automate repetitive tasks. Generally, these things, you will need them in the practice, actually. There is, of course, the part where you can model complex geometries, etc. But I think Grasshopper is better to model these complex geometries. And another advantage of Grasshopper is that actually you can do environmental simulations, too many type of environmental simulation, lighting, solar analysis, etc. You can do them here. Now, it's good. It would be good also to learn also this, especially Python, because it's very easy and you can do complex forms, and it's integrated with all the softwares. If you want, in the future, you will see that in the practice, many things regarding Revit that are repetitive. If you wanted to automate tasks, if you know this language, you will be able to develop Revit macros. It's like small softwares integrated or plugins integrated with Revit. And many people, they develop the softwares and they are doing business actually with them, not only develop for yourself. You can even make startup. And yes, if you want to develop another software, this kind of language, but this one is a little bit difficult. And there's this one also, which allow you Ruby, which allow you to develop SketchUp plugins. But I think the beginning should be here. So at least if you know these ones, it will be easy, for example, to learn this Python. Now, in the end, I hope that you know or you understand why actually we need to learn programming as architects. And thanks for your attention. And if you have any questions, please feel free to ask.
Thank you so much, Dr. Taki.
Welcome.
I hope everyone enjoyed the talk, gained many insights, and perhaps feel encouraged to try programming. If you have any questions, you can just type it in the chat box. Actually, there's already a question, but I think it was answered. Some people may feel that programming and coding is very complicated and overwhelming. What advice would you give for beginners to start programming?
Okay, good question anyway. As I mentioned, you have to understand that programming is not meant, it's like, you know, it's like you can learn programming for the very simple thing, which is to make you think better. Because I mentioned, if you learn programming, you will see that you can think in more systematic way. So this is already one very big advantage for everybody, not for only architects. And as you can see, as I mentioned, unfortunately here in Malaysia, maybe even in my country, but in this country, for example, I'm not sure which country, but in many countries, even in Europe, kids like this, that are very young, as you can see, and they started showing them the basic of programming. They don't know if these guys, they will be architects or they will go to computer science. They know that programming will teach them the logic, how to think, how to take decisions, why I should select, how I can give instructions to this little cat to go right on why and how. So as you can see here, they are developing program. They are kids, but they know how to develop an algorithm, basically. This is an algorithm, what they did. So as I mentioned, so if you want, since I'm not sure if you are degree or master, but don't think it's not the time to learn, actually. It's always the time. Even me now, I'm still learning Python, for example. Because I see there is many opportunities, actually. If I learn Python, I will be able to develop even, as I mentioned, kind of plugin for Revit. So I can even do a startup. So, but instead of learning Python, even though you are young, I think even if you invest your time in learning Python, it would be very good. And please take this programming as a hobby, not a task, as you mentioned, over complicated and overwhelming. But actually, if you are using a guitar, actually, instead of using a guitar, you can spend some time with program. You have to take it you have to make it as a hobby. Same thing as learning, for example, English. You can learn a language or Dynamo, for example, as you learn any other thing like a language. So I think, and I told you nowadays, if you want to get out of the crowd, because everybody now almost knows how to use SketchUp or even Revit. So these are the new skills that you need to have in your pocket in order to be good architect. So you can use, so for short, you can at least start from Dynamo. Dynamo is not complicated. It's the only nodes. You can, even without programming, you can use Dynamo. And if you want, of course, there is many documentation regarding Dynamo, but there is a forum, Dynamo forum. If you write in Google, Dynamo forum, actually, when you are learning Revit, any problem happens to you, you just post your question there. Many experts that are there actually. Even me, actually, when I was doing my PhD, because I used Dynamo, so I had many issues actually while I was learning and working on it. So always I ask a question and I will get an answer, and you can learn from previous discussions. So I think everything, you just need motivation and the willpower to start. And remember, you are still young, actually. I told you, even me, I'm still learning now. If you are bigger, you are still young.
Right. Thank you so much. We have another question from Iris. Do you have any suggested websites or platform where we can learn programming?
There is some websites. There is, I think, code.org or .com. I'm not really sure, but there is very known website actually. And there is even Khan Academy. They have some courses related to programming. But in YouTube, there is I forgot the name of the channel. I think ID Robot or something. Actually, they do very detailed tutorials of how to use Dynamo, actually, for example. So I think that one is very helpful. And of course, if you search in Google, you will find more, even those who I don't know, which I don't know.
Right. I have a question.
Yes.
Because my friend, she's doing coding. She's a computer science student.
Mm-hmm.
She talks about programming languages. Mm-hmm. So what's the difference? Because I was a bit confused about, like, when you talked about script programming, and then there's such as the visual programming.
Yeah. So as I mentioned, there is actually thousands of languages that we can use to program. But the most known one, they are here. These languages, we call them text-based computer languages. And of course, each one, it has advantage and disadvantage. And some, for example, like, for example, C# or C++, they are good to develop softwares, complete softwares. There is some what is it? This, for example, PL, SQL, and there is another one. I cannot see it, but some that are good to develop websites, because you know a website is a program also. But these ones, there is Python, for example. Python is very known to be easy, user friendly compared to other ones. But still, you need to learn it anyway, because it's language. When we say language, we have to learn the syntax, because it's like the grammar of a language in computer science. We call it syntax. So we have to learn it. Because in programming, if you write one letter wrong or one capital letter, it has a meaning. The things should be following the syntax of the language, which means you have to learn the language. But of course, I know these things, they may take time, but at least there is what you call it, visual programming. So instead of scripting line by line, you write text like this one. We can do this. So instead of writing this, we can use Dynamo. So this script is the same as this. So nowadays we don't really need to write all this text and know the syntax. Visual programming, they came to this AEC, Architectural and Engineering Construction Industry, in order to make things easy for architects and engineers, because usually architects and engineers, even though some of them they know how to do programming like this one, text-based, but usually they don't know. That's why they brought this visual programming to make it easy. So I think I answered your question.
Yes.
Mm-hmm.
Are there any more questions before we end the seminar? We have one question from Tan Jiahong. Will you recommend to use programming on BIM too?
Yeah, I told you, programming, even when you marry and you have children, it's good to teach them programming when they are kids. So programming as a whole, it's thumbs up always. Now to use it on BIM, of course it's good. And then, as I mentioned, Dynamo is connected to Revit, and you know Revit is the BIM authoring tool. So already, if you learn Dynamo and you start applying it, which means you are applying programming in Dynamo, which is a good thing. I know actually many architects, they are not computer scientists. They are very good in developing plugins for Revit. Imagine, when we say developing plugin, it means you will need to learn the language like this, not this one. Language like this. So they are architects and they are able to develop because they really like it. It's like they find it interesting to do this kind of program. Yeah, so always remember, it's like learning a language like English. It's not about this is for computer scientists. No, it's not my call. No, it's good to learn it, and you can learn it, and it will make the difference actually if you learn it.
All right. Thank you so much for answering. Maybe we will wait for a while. Maybe perhaps there is another question. In the meantime, any more advice you would give for people in programming and perhaps coding?
I think I took my time to give all the advices that I have. So me actually, it's not this one, it's like a regret, because me, when I was studying, when I was doing my degree, and I think, yeah, especially degree, I didn't really take a look to this programming like Grasshopper, because Dynamo that time it was not famous, but there was Grasshopper. I didn't get the advice, but now when I become old, as you can see, and I did some research and I can see what is happening in the industry, and it's like my area of expertise is BIM, and BIM is all about information. That's why I can see now it's very important, and that's why actually we are doing this talk. So it's like, in the beginning, I'm regretting that I didn't really learn programming when I was young. I mean, before this age. But anyway, I still have the courage actually to learn more about this kind of thing. So hopefully the participants will have the courage to take a look at least to this kind of program, at least visual programming.
I see.
There's
we'll learn while we're still young, yeah?
Yeah.
There's another question actually from Guma. Would you suggest we learn script programming first, or is it possible to start off with visual programming without learning script programming?
Yeah, my advice is to start by visual programming first. because it's more user friendly and it will not take time compared to text-based programming. Text-based programming, perhaps it will take amount of time to learn the syntax of the language, and you may not be motivated in the middle of the journey. So in the other hand, if you learn visual programming, I think it will be a good push for you to be encouraged to learn even text programming after that. So in summary, or to sum up, I think visual programming should be learned first, and then you can jump to text-based programming.
Okay. I think that's all for the questions. Thank you once again, Dr. Taki, for
Welcome.
all the insightful advices that you gave. And we have come to the end of this seminar. Thank you once again, everyone, for joining us for today's online lecture. We hope you enjoyed it. And keep in touch with our MASA's Instagram and Facebook for the next one. Until then, have a nice day, and we will catch you next time. Bye-bye, and thank you, Mr. Taki.
Bye-bye. Thanks. Thank you all. Bye.